And then number 10. Number 10 here. Okay, so this is another optimization question. So it says a square sheet of cardboard of side length A is used to make an open box by cutting equal squares from four corners of sides and folding up the sides. What size squares in terms of A should be cut out of the corners to obtain a box of maximum possible volume? What is the maximum possible volume in terms of A? Show all work and justification in your solution here. So I don't know if they give you a diagram here again, because this is actually pretty hard to visualize. I hope they do. Let me just check here. So they don't actually. So that sucks. But what I can do is, I don't know if I have enough time to actually explain this. And again, the solution is definitely incorrect here because I don't see any solutions here. There's no numbers here. But what I can do here is I can actually solve for, let me draw this out for you first. So I have some sort of square sheet. I'm making an open box, right? So this is gonna be a box in 3 dimensions here. So let me just draw out my box. And it's actually an open box. So this this top cover here is open, right? And I know that for a box here, I have a volume, and I want a volume here. A volume, so the volume of a box is simply just, I can use it's x times y times z, right? And this here, or a times b times c, it doesn't really matter what you kind of use. In this case, I use a, b, and c. So let me use a, b, and c here, where it's a, b, and then this here is c here. Doesn't really matter. It's just the product of those things. And again, this is the volume of a rectangular prism here, and this is going to equal, again, a minus 2x here. So a minus 2b, and then times a minus 2b times x here. So they used a different kind of a notation here, and they changed it up because, again, it says I want a side length of a, right? So my volume is going to equal a minus, I would say, I guess this is 2b, a minus 2b times b here. And then this here is going to be, I can use this to help me figure out my volume here. And what I'm going to have to do is I'm going to have to first, I need to isolate for one variable. Right now, currently, I have 2 variables that I have to work with. So, well, actually, what I have here is, I can isolate for a variable here for me to figure out, so I can plug this back into the, so I can actually do the derivative of this. So it says here differentiate at x equals minimum. So at x equals, basically if it's less than 0, thus maximum volume. So this solution here is, the logic is here, right? Because again, I'm basically taking the derivative of this volume and I'm setting it to 0, and I'm figuring out when is the function going to be negative. That will be my maximum volume here. So if I were to solve this problem, I would basically, let me FOIL this first. So I would get a squared minus 2b minus 2b, 2ba, sorry. No, this is minus 2ba minus 2ba. So this is minus 4ba plus 2b squared times b here. And this here is going to equal, I have a squared b minus 4b squared a, or actually 4ab squared plus 2b cubed here. And this here is our volume, right? And what I'm going to have to do is I'm going to actually take the derivative in respect to one of these variables here. And again, I don't have, and I want to find out the volume in terms of a, right? So basically, I'm going to take the derivative of d over v over db here, and this will give me a volume that is respected to a, right? Because again, I'm looking at what size squares in terms of a should be cut out of the corners to obtain a box of maximal possible volume, and it says what is the maximum possible volume in terms of A here. So again, I'm taking the derivative in respect to B. So again, this guy here is simply just A squared. This here would be, again, I would, again, 4A's are all the constants, right? So I don't have to worry about these guys here. This 2 is going to be brought down. So I'm going to have 2 times 4A here, which is 8A times B here. And then I'm going to have, for this guy here, is I have 3. I'm going to bring this down. I'm going to have 6 here. 3 times 2 is 6. And then this would be simply B squared here. And then I would basically set this guy to 0 to figure out the maximum volume here. So this here, I would set this to 0. And then I would have A squared. Or let me see, 6B squared minus 8AB plus A squared here. And then in this case, what I would have to do is I would have to actually I would factor in terms of B here to try to figure out if I have to figure out basically something in terms of B here. So in terms of the dimensions here. So this here would give me, if I were to solve for this this quadratic here. Again, this is simply a quadratic, right? Because I know that A here is a constant. So A is always a constant here. So basically, I would basically plug this into my my quadratic formula to figure out what my possible dimensions are in terms of A here. So this solution, so this is, I believe, all the work I can do for this problem here. And yeah, I think that's about it for this problem. Maybe I'll see if I can factor. I don't know if I can factor 6 times. Again, this number is a constant, right? So I don't know if I can actually factor this guy here. Because again, I have A squared here, so this here is a constant. But I could common factor these 2 guys out, but I don't think it's going to help me out here that much. I have a B here that's common, so I have 6B minus 8A plus 8 squared. It's not actually going to help me a lot. So basically, for this problem here, is I'm going to have to, basically now turn A into a fixed variable. So assign some number of A here to complete my quadratic equation here, so I can solve for this. So this here would be very, very similar to something that's ax squared plus bx plus c. And then I would have to assign some type of number of A to solve for this solution here. So again, this is all the work I can do for this this kind of problem here. And I can't verify my solution because the solution here is obviously incomplete. But this here is what I would be given if I were to set the derivative and take the derivative in terms of dv over dB to get me this formula here. And I set it to 0 to maximize the volume again. So again, another differentiation problem. So I'm going to say the solution is incomplete here. And then I'm going to say here what I got was, I got v here would equal basically A squared times B minus 4AB squared plus 2B cubed. And then if I get dV over dB would equal, this is A squared minus 8AB plus 6B squared. And then I can basically set this to 0 equals. I'm going to copy and paste these guys here. 6b squared. And yeah, that's all I can do with this problem here. Yeah, and setting derivative to 0 would maximize the volume. So I'm going to say solution here is incorrect because it's an incomplete solution here.